All right. So some of these are words we probably know. Some of these might be new, and that's okay. Scatter plot, we might know what that is. We should know what that is. What is a scatter plot?
A bunch of points on a graph.
Yeah, usually they look kind of like, this kind of deal. It's a bunch of little dots on a graph. What it is two quantitative data sets on one graph. So my x-axis will be one quantitative data set. My y-axis will be another different quantitative data set. Like we could do height would be one, and I don't know, foot length when we measured our fingers, arm span, any of those things. So it's two quantitative. What's up? Yeah, we're not using the rest of the top of that at all. That was a homework assignment that we did. 96 is just a large page, really close by to what we're doing today. That just happens to have open space. Thank you. It's two quantitative data sets. Compared in one graph would be how I would word it. So things like height versus arm span. When we did the measurement of our foot versus the measurement of our finger. We could do any sort of quantitative sets, and if we use two of them, we're going to wind up with a scatter plot. Just going to erase that word. We have a tool that we use to measure how strong the correlation is in our two data. We talked about correlation is where they're moving kind of similarly. But there's a way to measure how strong that correlation is, and it's called the R value. And what that is, I'm going to write this here. This is the measurement, or a measurement, of the strength of the relationship. And all R values are between -1 and 1. Every single one of them. A data set that is perfectly correlated could be 1. Like that would mean our line of best fit hits every single dot and every dot is on the line. And that would be a positive correlation. It could be that it is -1 and that would be a perfectly negative correlation. If it has a relationship of 0, that would be that there is no correlation in this data whatsoever. Even a little bit. And so we're going to look more specifically at how we can get a little bit more detail about the R value. That's what the rest of these are talking about, is these are going to be what a positive association does to the R value, what a negative association is to an R value. And then we're going to practice with this a bit, because R value is a little bit weird to wrap our brain around. They are. So a lot of these, I'm going to use them to reference our line of best fit, which is the line that goes through most points, or as close as we can, on these data sets. So a positive association would be that our line of best fit, which I'm just going to call LOBF, just got a little O. Line of best fit will have a positive slope. So our correlation, it's a positive correlation. And our R values are going to be greater than 0. So we will have a positive R value. It'll still be less than 1, but if it's more than 0 and less than 1, why are y'all laying on each other like that? I just look over and 3 of y'all had your head on the person next to each other. We're making some interesting choices back there, gentlemen. Just say, sometimes I think y'all are too good of friends. Not what I was saying. It's also,
It's more than friends. It's more than friends.
it's like we're trying to share chairs. It's just a little much. This would be line of best fit. I just abbreviated it because I didn't want to write the whole thing out. And I'm going to use line of best fit repeatedly. Because our negative association is very, very similar. But instead of us having a positive slope, our line of best fit will have a negative slope. So our R will be less than 0. It'll still be greater than -1, but it'll be less than 0. So positive and negative slopes help us see whether we are positive or negative in our association. So I'm just going to give a little thing over here. So if we have a positive slope, meaning our line of best fit goes up like that, that's what I mean by a positive slope. If we have a line of best fit that goes down like that, that would be a negative association. There, one is going down and the other one's going up. So just for visualization on that. So then we're going to talk about weak versus strong. And I'm actually going to start with strong association just because I feel like it's more intuitive. I don't know why they're reversed on here, but they are. So a strong association means my points are real close to that line. Like I could look at my graph and it is pretty darn close. I can really see where that line of best fit's going to be. All data points are close to line of best fit. Told you I was going to use line of best fit a bunch of times. So there's not any like specific number that we can look at and say, hey, this is where it becomes a strong association versus not a strong association. There's not like a cutoff point. It's relatively. But a strong association, I can really see where that's going to be. And what our strong associations are going to be is they're going to get closer to the extreme. So it's going to be closer to 1 for a positive association or closer to -1 for a negative association. So we could have a strong association that is negative, and that would look like this. So we could have a positive strong or we could have a negative strong. Both are strong associations. I can really very clearly see where that is. And those will be closer to 1 or -1. So a way to word that if you want to like to have that in your thing. So the absolute value of R gets close to 1. So the distance of R to 1 gets really, really small. So 0.9 is a very strong association. 0.2, not so much. So those not so much strong relationships, those would be our weak associations. And we kind of get a vibe of a line. Like, there's a line, but, Like we get the vibe of a line of best fit. So weak associations, the points are not all that close. to the line. So I'm going to do a couple of weak associations at the bottom, just like I did for my strong. So if I have a weak association, which I'm going to do my weak ones in purple, this is a fairly weak association. I could still put a line of best fit through it, and it can still have a positive correlation, but they're not super duper close together. Just like I could do the same thing with a negative correlation. I could have a fairly weak negative correlation. And the only difference between those is they're going to be a lot closer to 0. I'm going to put that in here. Closer to 0. So something like 0.1 is a very, very weak association. Something like 0.99 is a very, very strong association. And what we're going to do, our first activity for today, is we're going to practice seeing if we can play match 'em up with R values. So positive, negative, strong versus weak, and some graphs. We're going to do one set together, and then I'm going to have you guys do several of them on the computer. Because honestly, the website that has very lovely practice problems for this looks like it was created in about 1994. So the website looks super fun. What's up? Yes, dear.
When you say R values,
The number, it's a number and it's like a measurement for a bit. We're not going to have to calculate it. I'll show you how we find it. But like, I'm going to give us, so an R value of 0.9 would match which of these graphs. Basically is what we're going to look at. All right. So here is our first set of graphs. All 4 of these pictures have the same numbers. So we're deciding which of these numbers goes with which of these graphs. So take a look at these.
Wait, so it's a strong association, but it has like.
And you know, if you know you just got off the phone, you let that guy charge the phone more.
Positive one or like negative?
It'd be closer to negative 1 because it still has that strong slope. So what do we notice up here?
The ones on the left are facing different from the ones on the right.
Yes. The ones on the left, what do we think? Would they be positive associations or negative associations?
Negative.
Negative. So I know that these all seem to be negative over here. And that means these ones over here look to be what? Positive. Because they're kind of vaguely increasing. Like, that's what's making us think this. So, and we're going to use the numbers that were given here. So, which one do you want to look at first? 1, 2, 3, or 4?
2.
I've heard literally every single option.
4.
Nobody said 1.
I heard 1.
More 4 than 1.
Okay, all right, I'm going to change the view. Let's look at 2 and 4. I was honestly, none of those were the ones I was particularly expecting. I was expecting somebody to say 3 a lot. So we already said, looking at 2 and 4, we're pretty sure that these are positive. They look like positive associations. So that means I know it's not going to be that negative 0.71, so I can eliminate that one out. Or the negative 1. On both of these, we've decided they're both positive. So they both have the options of 0.65 and 0.53. Which of those is stronger, 0.65 or 0.53? What makes it strong? If it's close to
0. 1.
0 means I got nothing. There's no association. So 0 means there is no connection between these two. So, which is stronger, 0.3 or sorry, 0.53 or 0.65? 0.65 is stronger. So this is stronger. What makes you say that? 4 is a little less tightly clustered, right? So if I put my line of best fit, which I'm going to make white. So if I draw a line through here, those dots are fairly close together, whereas these ones, they're a lot less close to that line. So 4 is going to be the 0.53 because it's a little bit weaker. And 2 is going to be the 0.65. So we're using the values that are available here to kind of mix and match. So then let's look over at 1 and 3. And we've already used those positive values, so we know it's not going to be these guys. What do we think about these two? Which is going to be stronger, the minus 0.7 or the minus 1? Minus 1 is going to be stronger because it's farther from 0. The farther from 0 we are, the stronger it gets. So this is stronger. So which of these graphs goes with the minus 1? Yeah, because what a minus 1 R value means is that all of our points, if I'm really good at drawing a line, are pretty much right on that thing. When I drew my line, I covered up. If I was good at drawing straight lines on an iPad, it would have covered up all those yellow dots. Right on top. So this one does have that R value of minus 1. So we can process of elimination, figure out number 1. But also, it's that same kind of vibe. If I look at my line of best fit here, these are pretty close. They're not super far. They are closer to the line than even these ones were. And we said this was the stronger association. So these points are closer to the line than even these ones were. So it's going to have an even stronger association. So that's why it's going to be that negative 0.7. Okay? We see how those are connecting, kind of like that. Because I'm going to send you to a website that has these, and it's going to pop up random graphs and random numbers for you to try and match them up. It'll have a page just like this, and it's the same vibe, where it gives you that same set of numbers for each 4. Okay? So, that link is on Canvas, and I believe it is called Practicing Connecting R Values or something like that. And I want you to get 8 graphs right. So go through them. It'll give you 4 at a time. I want you to get 8 graphs right. I'm just trying to remember what I named it. So in the Unit 8 page, so you can either click on the Unit 8 button or on the module page that says all links and information, including dates and homework. And we've got the correlation coefficient matching practice. And then we have a data set that we're going to work with today as well. And the website is beautifully modern. Definitely does not look like it was made in 1994. It looks like this. Not even. This is the one. It looks like 1994. It's so beautiful. So go with these. See if what we can do to kind of figure out where they're going. Once you decided which one it was, you hit the check answers, and it'll give you smiley faces if you're right. And they will have different questions for different people. But like, it'll give you smiley face versus frowny face. And the images are very small, but that's all it's saying. It's smiley face versus frowny face. And their smiley face is like the least happy smiley face ever.
It's more depressed smiley.
It's more, I survived this than I enjoyed this. So, which kind of fits.
I survived survive the great math equation.
At least I'm not making you calculate it.
We already know I've calculated this.
I know. You are unique in this last one.
What?
You are unique.
Yeah, me sitting here is just to remind you that I'm here just to settle my problems.
I know.
Hey, at least I'm not lying to you. I'm not gonna hide it out on all my songs.
Yeah. Once you get 8 of those graphs right, then you'll grab the data set off the Canvas page, and we're going to try and make a scatter plot for our arm span versus height data. And we're going to try and find our least squares line and see if we can find our R value.
Glasses you had, bro.
What the? Look, bro. Look. Handle.
I chose the right answer first. Like they're really close.
It is the least smiley of the smiley faces available. Like that is the most meh smiley face ever. Oh.
So I have to take a photo of each time, right?
No. I have to submit it. Awesome. Once you have it, then you're gonna go grab our data set.
Then you get mine.
Those two.
Because you wanted to eight greens. Not one, there's only 4 on page. We'll go for 8 green ones and then see if we can grab the data set. What's up?
Right, this is a positive correlation,
Mm-hmm.
and it's weak,
And it's fairly weak.
just in case you didn't believe me.
You're right.
I took this in AP psychology.
Yeah. There's this will apply in a lot of different courses. Yeah. We're just gonna put a sketch in it. And you can put it on. There's a plot available there. You don't have to be super detailed on it. So we can get it and then get your line listed in, which you can get all the software and see if we can figure out where the R value is.
It was stopping.
Yeah, if it's a negative slope, then it's gonna have a negative correlation. So if it's going kind of, no. No, I did in fact say 8. 8 green ones. Get 8 green ones. I know. If you click on the bottom right, it says get more plots.
So I got 4 right now.
So click get more plots, and then it'll give you 4 new ones.
I'm on round 7.
Awesome. Once you have 8, go back to the data set and do the next thing. Because we don't need to do millions of them unless we triple it. Because there's 4 graphs out of each one. You don't need to do 8 sets, do 8 plots.
That's the height. Look.
Oh, good job.
So there's 4.
That's the height.
So then go grab the data set.
I got you.
You're doing great. So go grab the data set and do that. Sit there just like we're doing scatter plot between our height and our arm span. Yes, sir.
I can't do this on here.
Fantastic. So let's see if we can do questions on the next sheet. So the bottom ones are more about handwriting, but these ones are very related to that digital equation. And we're going to talk through it in just a minute. I'm going to let everybody get a chance to do that. So when you've gotten your 8, go and grab the data set from the Canvas page. And we're going to do arm span versus height. Arm span and height is what we're looking for.
You gotta do 8. You gotta do 8. You gotta be.
8 graphs, not 8 sets.
Unfortunately, nothing I know today. Thank you. I can't do that.
He always puts it for today after we. That's why I do.
Just enough. Huh? I know. I don't. Second. Exactly. Exactly. It's gonna work. I'll put on the wrong one. Are you special?
Hey. Nice. Nice.
How first the wrong one? Thank you, God.
And you can do it on your own phone instead of watching her makeup.
First now?
That's not her doing her makeup.
Okay, we don't need to watch her. I can tell a story time before doing it. Get rid of it.
It's a no.
You sit there right at the little table.
It's a trend.
What is bro?
You know what it's not a trend
What is
in?
bro watching on his phone?
It is not a trend line of our data for our class.
Russians were posting a video and it's on my 40 page.
Awesome, but it's not on our for you to do during class page.
He's just not even him. You reposted makeup tutorials?
No, that's not what I'm doing.
Alright.
Trying to do the makeup.
So let's work on what we're doing in here, because that's definitely not. It is So you would need to, you're trying to make a graph, but I don't know how to do it on your phone. It's a lot easier to do it with your computer.
There you go, you did it. Now you've got a, he has a computer, Francis is from.
It does make this.
Well, then we could just let Francis use his own computer.
His computer did.
I have chargers.
Yeah, but I don't use Chromebooks.
He has a personal computer.
Issued a Chromebook.
I use my own personal issue Chromebook.
Well, then you gotta bring your own personal charger, because we use software for this a lot.
Type.
I think you should give him his phone, that would make use of.
So, there we go. So I feel like most of us have gotten through the R value part. So then what you're going to do is you're going to pull up our data set that's on Canvas. That is our class data that I've tidied up. We talked about it last week that we needed to clean the data because there was some where we had weird units or someone said their height was 5.5 centimeters. So this is our data from the survey. All I did was clean it up and get rid of like those units and things. So we wanted to create a graph that was arm span versus height. So when you're in software, you say, I would like a graph. And you can either click and drag, because I want to have height on one of them, and I can click and drag it here. Or I can click on here and pick out of the list of all the titles. So I need arm span here. And you can do it either way. It doesn't matter how we get there. I want arm span versus height. Though we are going to be kind of sketching this in our book to get a vibe of it. And they have my two labels switched. So what I can do to switch them is I can just, click and drag it there, swap them, and it'll swap them. So if I don't like how things are oriented, I can do that. I know. So I'm actually going to minimize the data set behind it because it's in the way. And I'm going to make my graph a little bit bigger. To get to our line of best fit, click on the ruler, and it's actually called our least squares line. And that calculates our actual least squares line, which is our line of best fit. This is the bestest of best fits. And since we all have the same data, we should have the same equation. Because we don't have different data sets.
What website are you on?
The same website we've been using.
No, I'm not, I'm talking about.
I was going to say, focus on your own computer. If I need to, I will pull up the Bloxies for us.
The what?
The Bloxy.
What is that?
Oh, it's the screen watcher where I can control what pages y'all are allowed to be on during class.
Well, I don't have a problem with my computer, it's his computer that I was having issues.
We're not going to judge people based on which off-topic we're using. I'm just saying, especially when we are not on topic. We do not get to issue judgment on other people's off-topicness. I was like, 100%, I got you. I was like, but we don't get to start stuff, especially when we are watching more. I'm going to go with Get Ready With Me videos.
Makeup tutorial, get ready with me.
I was like, is it Halloween tutorials?
Get
Slay.
ready.
Get ready for me to go to a basketball.
Let's get ready for Halloween. Let's slay. All right. So in CodeApp, it'll give us the bestest of best fit lines. It gives us the equation for us. And then it gives us R squared. So it's not exactly the R value. It's close. It's kind of similar. It still measures the strength. The reason they use R squared is because then it's not positive versus negative, and it's easier to see which one's stronger, whether it's positive or negative. It's the reason I use R squared, but I kind of like being able to tell whether it is a positive or negative correlation from the value. So if we have our equation like this, so our equation is in here, where it says arm span equals, mine says 1.11 height minus 14.7. The heck does that mean?
It means chaos.
Chaos is not wrong, but not particularly helpful. All right, so when they give us equations like this, they want us to look for our variables. This is my y, and this is my x. So y equals 1.11x minus 14.7.
Where's your X on the board?
What's up?
Why is your X on the board?
I don't get what our joke is trying to be. I'm very confused.
Your X.
Yeah, they're in K hallway. Just saying.
Oh.
The reason they don't go down K hallway. The graduation photos.
Oh,
I attended here, remember?
you went there.
You're that old?
Yes, I am that old. All right, so this is the last homework of the chapter. It's homework 9, and it uses that same scatter plot.